Let's analyze and graph this quadratic, this parabola, when it's written in standard form, meaning everything has been multiplied out. There's nothing in parentheses. There's nothing squared in parentheses. It's all been multiplied out. I think it's probably going to be first helpful to identify what a, b, and c are. Those are your coefficients of x squared, your coefficients of x, and then your constant at the end. Identifying those values should help me fill out a couple of these blanks down here in my analysis fairly quickly. The c value, when you're in standard form, always represents your y-intercept. So I know that this graph is going to cross the y-axis at 0, 6. And actually, let's go ahead and just get that point on the graph right away. 1, 2, 3, 4, 5, 6. We have 1 point. I'm going to look for 5 points when I'm done graphing this. Another blank that I can fill out really easily on these analysis problems is the domain. The domain describes how far left or right the graph goes. And since a parabola will open forever as it goes side to side, my domain is going to be all reals, or positive infinity to negative infinity. Next up, I'm going to work on finding my axis of symmetry and my vertex. Now, there's ways to do this on the calculator using the min and max feature, and if you know how to do those, great. I want to show you how to do this by hand, though. To find your axis of symmetry, you're going to use the equation x equals the opposite of b over 2a. Okay? So because I've identified those variables, I can see that b is negative 8, so the opposite of b would be positive 8. Divided by 2 times the a value, which is also 2. So when I simplify this, I get 8 over 4. Which just works out to be 2. So my axis of symmetry then is going to be x equals, and yes, I do want to make sure you have the x equals in there so I know you know it's a vertical line. Let's go ahead and draw that vertical line in. So somewhere along that axis of symmetry is where my vertex is going to exist. I don't have the y value though, but that's going to be the next thing that I figure out. To find my vertex then, well, I know the x value. It's going to be 2. It's going to be along that axis of symmetry. But I need to find the y that matches up with this. Again, there's ways to do it on the calculator, which we'll talk about setting up a table in a second. But again, I want to just show you this part by hand. To find your output then, let's plug in 2 for x back in that original equation. So y is going to equal 2 times 2 squared. I'm plugging in 2 for x. Minus 8 times 2. And then plus 6. So just be careful on order of operations as you work this out. First do exponents, so 2 squared gets you 4. 4 times 2 is 8. Minus 16 and plus 6. And once I work all this out, I find out that my y value comes out to be negative 2. And so I have the second value of my vertex, or the second number in my coordinate. I know my vertex is going to be now at the point 2, negative 2. So let's get that point graphed right there on the axis of symmetry. Okay? Now for these last 3, I don't know about you, but I need to see the graph to help me figure out what the range is, how high and how low the graph goes, and then the intervals where it's increasing or decreasing. So at this point, I'm going to need a few more values on my graph. Well, using symmetry, I know there's going to be a point right here. Since there's a point 2 spaces in front of the axis of symmetry, there has to be 2 points behind it, and so on. But really at this point, I'm not really looking forward to plugging in a bunch of values by hand, because I said I want 5 of them. So what I would do is I'd probably switch over and look at the table on your calculator. I would make sure that the vertex is kind of centered there in our table when we look at coordinates, and then we can pick 2 points above, and we can pick 2 points below it. Oops, I'm sorry, that's not my axis. That's not my vertex. Oops. My vertex was at 2, negative 2. I would then pick 2 x values above, pick 2 x values below, and then because we're using symmetry, I know whatever the output is up here, it should match up down here. Just a trick that I like to use, but you can certainly find any x values you want. So I'm going to assume that you guys have done this, or can pause the video and do this, but checking my table, I find those other coordinates to be points on my graph. Well, I've already plotted the vertex. I plotted this one, and then I used symmetry to find this one. So really the last 2 points I need are 1, 0, which would be right there, and then 3, 0, which would be right there. Okay? So let's go ahead and get this parabola drawn in. We want to make sure it's as curved as possible. So as best you can, make a nice smooth curve. You're trying to make a roller coaster. There's no pointy parts in roller coasters. So we'll say that's our parabola. Now that I see it, I can go and answer these final questions. Range is going to be how low the graph goes to how high the graph goes. Well, the lowest this graph goes is negative 2. So I'll start there. It then increases up towards positive infinity. It goes up forever. The other thing I want to be careful of is when I describe my range, whether I'm using square brackets, which means I can actually get to that point. I can actually get to negative 2, versus parentheses, which means I cannot get to infinity. So the range will have 1 square bracket when we're doing this. All right, last part, and this is where some people get confused. is I want to describe the intervals where I'm increasing and the intervals where I'm decreasing. These are always only going to be x coordinates. So here's how I think of it. Take a look, pretend this was a roller coaster and you're riding the roller coaster from left to right. Well, as I'm starting over here, I can see that the roller coaster is decreasing down to that axis of symmetry. So we can start to fill out the intervals where this is decreasing. It's decreasing from negative infinity until I hit that wall. Remember, we're trying to look at just x values. So I'm decreasing from negative infinity to 2. And intervals for increasing and decreasing always only use parentheses. If I continue on my roller coaster then from that 2 onwards to infinity, I can see that now my graph is increasing. I'm climbing up the roller coaster. So my graph will be increasing from the interval 2, the x value, to positive infinity. Here are 2 more that I'm going to have you guys try. I'm not going to talk all the way through them, but I'll kind of get you started. These are in standard form. What I want to do right away, though, is identify what A, B, and C are, because I picked a couple that had missing values. In this case, A is -1. That's my coefficient of x squared. 3 is my constant, or is the C value. I don't have a B value. It's equal to 0. So that'll affect how we, when we set up our opposite of B over 2A formula. For the second graph over here, if I set up A, B, and C again, A is equal to 1/2. This time I do have the B value, that's -6, the coefficient of x. I don't have a C value, though. That's equal to 0. So what I'd like you to do is, I guess, pause the video and try these. If you let it play through for a couple seconds, my answers will pop up, but I'm not going to talk through all of these answers. So there's the first part of my problem. You'll see I found the y-intercept just by using the C value. Again, my domain was just negative infinity to positive infinity, and you saw my work pop up for how I found the axis of symmetry to find the x value, and then plugged in the x value to find the y to finish writing my vertex. For these last 3, the range, and then where I'm decreasing and increasing, I'm going to want to make a sketch. So again, if you pause the video and want to try these on your own, you can do that. Otherwise, let it play through. And real quick, you'll see my sketches pop up, and then how I determine the range and where it's increasing and decreasing after that. So you'll notice I also noted whether the parabola opened up or down when I made my sketch. For my range on that first one, notice that my range went from negative infinity, the low point, to the high point, which was positive 3. My decreasing interval was 0 to infinity, and then where I was increasing was negative infinity to 0. Remember, those use x values. Okay. That second graph, my range, my lowest point was negative 18. That's the only time we're using y values, and then it went all the way up to positive infinity. Notice the square bracket around negative 18, which means I can get there. And then finally, my decreasing, increasing intervals, again using just x values.